Hello and welcome to my tutorial. The scope of this tutorial will be to acquire LiDAR point cloud data and to clean it up so it can later be imported into AutoCAD Civil 3D, which will be part 2 of this tutorial. To begin with, I've started with the LiDAR site for the state of Iowa. Now this is geotree.uni.edu. I can zoom in to a study area that I want to look at. In this case, I'm going to zoom into Story County, going to zoom into this municipality. And the segments that I want to look at are these two 1 mile by 1 mile sections, which my study area will fall in between. I can use this tool up here to select the areas that I'm looking at. Could just make a box around there, and then when I'm done, I'm going to double left click, and this box will come up. It shows me that I've selected 2 point cloud files in that extent. So I'm going to click on both of them to download. You can see I've tried this before, and I'm going to navigate to where these are in the folder. Going to extract them. I'm going to drop them off in a folder that I've already prepared. Now notice that the extension on these files is .7z. Now this uses the .7zip open source software to uncompress it. If you do not have it, you should download it now. I'll include links in my video. So I'm going to click extract here. And now that this is finished, I have .las files, which are the most common point cloud files to be returned from really any source, not just statewide aerial LiDAR. Now that we have these files, these raw data files, I'm going to want to clean these up, especially for large data files. Most CAD softwares are not able to handle all of the data depending on the extents. So what we're going to do is I'm going to open the software called CloudCompare, which does similar things to many other softwares, but I like the combination of different tools and the ease at which it can be used. So I'm going to navigate up here to the Open folder. I'm going to select those 2 .las files which we previously downloaded. And it's going to ask me if I want to bring in all of the different fields, and I will say yes. It's going to tell me that the current coordinates are too big, and do you want to translate? And I will accept. Later it will translate it back to the correct coordinate system. Hit yes. Hit, and now we've got the second one. We'll hit yes. So now we've brought in 2 point clouds, and it's going to become easier to work with them if we combine them together, so we do not have to perform the same operations multiple times. So I go up here to edit, and then scroll down to merge, and I'm going to hit enter, accept that, and get rid of this little pop-up. And then I have this combined file which is easier to work with. We can see here, if we scroll down to properties, that it has somewhere around 8 million points, which is relatively easy to work with. However, we can make it better. I'm going to show you how to clean this up a little bit. First, we're going to want to trim it down to the area that is in our study. And it's kind of difficult to see what we're actually working with because of the way that the display is. So what I can do is I'll go down here to scalar fields and change it from point source ID to intensity. Now this gives me a little bit clearer idea about what is the site that we're looking at. Now I can see this is the area I want to clip out. Now if I have this point cloud selected in my DB tree, I can go up and navigate to this segment button. Now if I open up this toolbar up here, which comes up, I can click activate point polyline selection. Now I'll go and left click around the edges of the boundary that I'm looking at. And then when I'm done, I can right click and then click this button called Segment In, and it's going to give me a preview about what's going to be segmented. And when I like the selection that I've made, I'm going to click the check mark, Confirm Segmentation. Now I'm going to turn off what was remaining in the point cloud, and we can see, yes, this is the study area that we wanted to look at. Now from here, I'm going to take a look at the point clouds more carefully. Zoom in, and I can see a lot of these points exist on what are now buildings, and a lot of them are also trees. However, I'm not really all that interested in these points, as they do not reflect the ground elevation, which is what I am after. So what I'm going to do is I'm going to filter these down. First, what I need to do is I need to change the view from intensity to classification. Now classification for these point clouds, it already indicates to me what is each point referencing in the real world. And I already know that the standard reference for ground points is 2. So I'm going to go up to this option and say filter points by value. And I'm going to have my minimum at 1.1, so I do not capture the 1 points, which I believe are water. I'm going to go to 2.1, so I do not capture points which are classified as 3. I'm going to hit OK. And we can already see now where these blue points are and the black areas are, where we've removed points. Now this does create some issues for the land in between here, as it essentially removes it. And there are some QA/QC issues going on here because of the gaps, which I'm not going to address in this tutorial. Now, if we look more carefully at how big is this file now, we can see that we are down to around 1.5 million points, which is much better than what we started at with 8 million. However, we can still get it down even further. We noticed some of these points are really quite close together, and they are largely reflecting the same geometry. So what we can do is we can downsample this. If we go up to Edit, and then go to Subsample, we can narrow it down by space. If I put in 1, I believe that this is in meters. So this means that every 3 feet or so, we will have 1 point, and then another point 3 more feet away at least. So I hit OK, and it will do this for me. And I can take a look at how many points are now in this file. And it looks like 800,000. And we can look at this over here, and it looks like we have more of a wide gap in between points. From here, this is the file that we're looking for. Just the study area, just ground points, and somewhat less dense of a point cloud. I'm going to go up here and click Save when I have this one selected. And I'm just going to call it Existing Ground. And it already has selected the .las format, which is what I want. It's going to ask me if I want the original resolution. I'll hit OK. And now we have just created the point cloud that has been sampled to the areas that we want. Now I'm going to finish this tutorial, and if you want to continue, feel free to do so. Thanks for watching.